So, an identity matrix. When you have, does anybody know in math general, what's an identity? It's when it's the same thing. So like, or think of, your identity is who you are. Okay? Identity in math is when it's the same thing kind of thing. So, for an identity matrix, which I to the N, I meaning identity, is the, the symbols for it. The main diagonal are all ones, and all other entry are zeros. So what method did we do that had something that looked like that? My mind, the what? The reduced row echelon, right. Okay. So if I have an identity of a 2 by 2, my diagonals are going to be 1, the rest are zeros. If I have a 3 by 3 identity, then my main diagonals are 1, and everything else are the zeros. Good? Okay. It is a multiplicative identity. Oh, you can, when you multiply, all your multiplication rules go. All right. Your inverse of a matrix is similar to a reciprocal for your number. And we use this as the symbol, just like you do for your real number system. But not every matrix has an actual inverse. Okay? When it does, it is said to be non-singular because you have more than one. But if it doesn't have an inverse, then it is singular. All right, so how do you find the inverse of the matrix? So, step 1, form your matrix, okay, you're going to have A and your identity, okay? This is a 2 by 2, right? That means I'm going to be doing my A and an identity of a 2. All right, are you with me? So, A is 2, 1, 1, and 1. And my identity is 1, 0, 0, 1. Good? All right, step 2. Transform this, what we have here, into RREF. There are 2 ways we can do reduced row echelon form. What's one way? You can do it in the calculator, or what's the other way? Remember how we tried to get everything to, so we would do multiply row 2 by a -2 and add it to it. We can do row operations. Which ones do you want to do? Heck, yes, we're going to do the calculator. So, 2, 1, 1, 0, 1101. Can I borrow your calculator for a minute?
Yeah, it's just,
I'll plug it in while we're doing it then too. Alright, so I hit matrix, math, reduced row is B, and I have a 2 by, come on, a 2 by 4. And so I put that in there. And I get step 3, which is 1, 0, 1, negative 1, and 0, 1, negative 1, 2. Okay? So the rule is that the identity matrix is on the left of your bar. So my bar was here. So my identity matrix is going to be, or my inverse, I'm sorry. 1, negative 1, negative 1, and 2. Easy peasy. Good?
you always
Is-
take the matrix given to you and put in the I.
Or I3. If it's a 3 by 3, then you use an I3. If it's a 4 by 4, you're going to use an I4.
And then put in.
And then whatever on the left side is your inverse. Okay? So basically, you use your identity and you get your inverse. Want to do one more? Sure. Love to. Okay, so I have a 2 by 2. So what identity do I want? I'm going to use a 2. So it's going to be an identity of a 2. So I have 4, 6, 2, and 3. There's my A. And my 2 by 2 identity is that.
Is that always going to be?
Unless it's a 3 by 3 or a 4 by 4. You use whatever identity. If it's a 3 by 3 identity, then it's going to look like this. If it's a 4, then you just have 4 ones and all.
Okay.
Okay? All right, step 2. We're going to use a reduced row echelon. So, reduced row. And I have a 2 by 4 again. So 4, 6, 1, 0, 2, 3, 0, 1. And now I get 1.5, 0, 0, 0.51, and negative 2. Okay. Now, question for you. When we're looking at this, my answer last time, because I'm doing reduced row echelon, right? Oops, I just got marker on your screen, sorry. Do I have 1 in my diagonals on this one? Okay, so am I in reduced row echelon form? No. So what did it mean when I had, if I'm not, what do you think it would mean if I'm not in reduced row echelon? That means it has no inverse. Okay? So if you get where we had the nice reduced row, there's your inverse. If you're not in reduced row, there's no inverse.
So that'd be called singular.
So it's singular, yeah. And if there's no inverse, we won't be able to solve that system that way, which we'll do tomorrow.